Example 5.3. The prism has a refractive index of 1.66. Two light rays, R1 and R2, are parallel as they enter the prism. What is the angle between them after they emerge? So the first thing I got to do here is that I need to draw a ray diagram that shows what the emerging rays look like after passing through the prism. So the first thing I'll do here is that I have an image that I want to look at this. And here's my ray image right here. So what I'm going to do here is I'm going to take a straight edge. And the first thing I got to do is that note that ray 1 and ray 2 are perpendicular to the boundary. So what this is telling me here is that these guys are perpendicular to the boundary. So that implies no refraction. So when I look at this thing, I'm going to look at these rays coming in, and let me use a straight edge to try to do a nice job, clean job at least. And so I'm seeing my ray, and it's going to go straight to right there. And this one's going to do the exact same thing. And now what's going to happen here is that now light is coming in from a higher index to a lower index, and it should therefore refract away from the normal. So the first thing I got to do here is that I got to go draw my normal here. So I'm going to say that right here, this is my normal. This will be my normal 1. And then I have a second normal over here, which I'll just hide, of course. And then here's my second normal, right? And this one's normal 2. So now what's going to happen? These rays are going to bend away from the normal here. So when I look at this thing, that means here is that this is the ray that occurs that's going to be what? Unrefracted, right? This is the unrefracted path. And again, I do the same thing for this guy here. Now, as a reference point, what I'm going to do here is that I'm going to draw a line in the middle of this guy. Okay. So that means in order to talk about the light ray that I'm going to be looking at, it's going to be referenced to something like that. So now look what happens. The emerging ray, we already agree that this is the unrefracted ray, right? This guy's also unrefracted. And now the rays are going to cross. So let's say here that they cross right here. So if I look at this thing, then I'm looking at my ray, and it's going to cross right here. And look how look what it's doing. What is it doing? It's bending away from the normal. And the same thing also has to happen to this other ray. It has to bend away from the normal. Now, because these guys are symmetric, that means they're going to cross the line. They're going to cross at some point in the middle. So what I'm seeing here is that here's my ray here, and what we're looking for is we're looking for this angle right here. So if I look at this, I'm going to call one of these, the one that I'm going to focus on is on this guy. This angle I'm going to call beta. So therefore, the spread of the emerging beams is 2 beta. So our job is to calculate what beta is for that. And so let's get to it. So what I'm going to do now is that I'm only going to focus on one ray. I'm going to focus on ray 1 because I know ray 2 is going to be just the opposite, but it has the exact same details. So now I'm going to look at the refraction of ray R1. So what I'm going to do here is that I'm going to only draw out half of the prism. And identify angles required to calculate beta. Okay, so here I go. So what I did here is that I've already constructed half of the prism. And so what I'm going to do here is that I'm going to come in here and I'm going to paste it in just to save time. So what I want to do here is that I want to see if I can line that up, and that looks pretty good right there. So what you're seeing here is that this is the normal of the second surface. So now what I need to do here is that I'm going to define this point right here, and I'm going to call this point A. And I know that the angles, the upper top angle is 25 degrees for both. So now what I need to do is that I need to now set it up and start to identify all of the angles here. So let's start doing that. So the first thing I'm going to do is that I need to define all the angles to calculate beta. So the first thing I'm going to look at is that I'm going to look at, so what does Snell's law tells us? Snell's law defines two angles. So Snell's law defines two angles. And these angles, according to Snell's law, is going to be, look what happens here now. What comes in, it's going to be n of glass times the sine of theta 1 equals n of air times sine of theta 2. So what are these angles? So what I'm going to do here is that I'm going to look at my normal and continue my normal all the way down. So if I do that, it looks like this. So that's my normal. So then what you're seeing here is that this angle here has to be theta 1. That's the one in the glass. And now what we saw earlier here is that there was a refraction of light going towards the middle of this thing right here. So one of the things that I'll do here is that I'm going to draw this line. This is the same line that I drew up here. Look at that middle line. It's a black line. So what I'm going to do here is that I'm going to continue this line right here. And I'm just going to draw it right along here. Okay, so that's that center line here, right? So this is the center line. And again, that black line there is the center. So now what happens is that you could see ray 1 now refracts. So as it refracts, it's going to be doing something like this here. Let's say that it crosses right here. So now what you're seeing here is that this angle is beta. And so therefore, that angle right there is beta. So our job is to calculate what that angle is. So again, this tells me here that then this angle right here is our refracted angle theta 2. So I've now defined two angles that's looking like that. So remember, I called this end glass, but we already know that end glass, and this, let me write this here just to make sure that we're clear, where n of glass, they call it 1.66. So here we go. Now what I'm going to do here is that to continue to define these angles, I'm going to drop a perpendicular line. I'm going to draw a perpendicular line from point A. And what I mean by that is that I'm going to be doing this here. So I'm going to choose my colors very carefully here. So look what I'm doing. So if I draw this perpendicular line right here, note that this guy now is a right triangle. And so as soon as I draw that, there are three angles. There are three angles, X, Y, and Z defined. So how am I going to define them? So this angle here, I'm going to call that X. I'm going to call this guy right here Y, and then I'm going to call this little angle Z. So now what you want to pay attention to is that, look what I'm going to do now. I'm going to take my red and I'm going to create a red triangle. So I'm going to follow this line all the way over to here and see how I now have a red triangle. So what I'm seeing here is that this red triangle defines the angle beta, and this is what we want. So what you're seeing here is that we know that the sum of all of the angles have to equal 180. So if I look at this thing, I know that the angles has to equal 180 degrees. And look what I'm doing. So I'm going to start with beta. So I got beta plus Z plus Y plus the 90-degree angle. And so this really shows that we're really saying that 90 degrees has to equal Y plus Z plus beta. And this is what we're after. This is how we're going to calculate the beta angle. So whatever we got to do is we got to calculate Y and we got to calculate Z. So let's go start to do that now. So we're going to do this step by step. Here I go. So now we are calculating the angles. Okay. Once again, we know that the sum of all of the angles of a triangle have to equal 180. Okay, so here we go. So remember, the sum of all angles inside a triangle is 180 degrees. I know I just said that up above, but this plays a huge role. So the first thing I'm going to go after is I'm going to go after the angle theta 1. Okay, so now let's look at the angle theta 1. So look at this corner right here. So what you're seeing here is that, note that this guy right here, that has to be 90 degrees. So if I was to redraw this triangle, it looks something like this. So I have a vertical portion that looks like this, right? So I have a portion that looks like this. Now, when I look at my ray coming in, it's coming in like this here. And what you're seeing here is that along this line right here, this is the normal. So if this angle right here is 25 degrees, and this angle here is 90 degrees, we have no choice but to say that this angle here has to be 65 degrees. But wait a minute, look at right here. This tells me that this is another right triangle. If this is another right triangle, then the sum of these angles has to be 90 degrees, which then tells me that the angle from here to here, which is theta 1 must be 25 degrees. So right away, using basic geometry, we see that theta 1 is 25 degrees. So now the next angle that I'm going to calculate, note that if I know what theta 1 is, note I could get x and I could get y quite easily. So let's do that. So now our next angle here is that we're going to calculate angles x and y using the same principles here. So now look what happens. I know what theta 1 is, and look at that right triangle right there. So when I look at this thing, here's what I'm going to see here. I have my ray 1 coming in like this, and then I have my normal. So I should be careful here, because if I look at this guy, here's this guy coming in, right? That's the edge of the prism. So then the normal has to be perpendicular to this. And again, this is the normal. So when you're looking at this, you can see here is that this is my perpendicular bisector right there. So now let's start filling these guys in. We already said that this is theta 1, which is 25 degrees. But look, this right here is a right angle. So if that's a right angle, this makes this angle from here to here. How do I define this angle? This angle from here to here, you could see here is that this angle is x. And then this angle here is y. So right away, what I could see here is that, note, the theta 1 and the red perpendicular bisector form a 90-degree angle. So then this tells me here that I'm going to get right from here, right at that spot here, you're seeing that this guy's telling me that this is going to be 90 degrees, has to equal 25 degrees plus x, which then immediately tells you that x has to be 60 degrees. Not 60, but 65 degrees. Now, y is interesting because if you look at y, look at what's really happening here. This angle here is 25 degrees. So then right away, this angle of y has to be the same as 25 degrees. So just by inspection, we then say here that y has to also be 25 degrees. So now I have all of my angles defined except the angle what? I don't know z, I don't know theta 2, and I need those to get beta. So now let's go in and look at the next thing here. So what we're going to do here is that the first thing that you want to pay attention is right here. So when you look at point A, note that there's a 90-degree angle right here. And that tells us that theta 2 plus z equals 90 degrees. So if you look at that triangle, so I'm gonna try to go get angles. What did I call them? Z and theta 2. So the first thing that you should be looking at here is that there is a right triangle at point A. And the way you see that right triangle is it goes like this. So here's my normal. And then what you're seeing here is that then here's the lens, not the lens, but the prism. This angle here, by definition, has to be a right triangle. Now, when I look at my ray that emerges, you're seeing here that we define this angle right here as theta 2. Remember, this is the normal. And then this guy right here, this is the surface of prism. And so what we did here is that we defined this angle Z to be the angle between this guy and that guy right there. So right away, what we could see here is that this tells us here is that 90 degrees is then going to be theta 2 plus Z. So if I solve for theta 2, I automatically know what Z is. So let's apply Snell's law. So what we're going to do now is that if you look at the triangle, we're going to use Snell's law. So the incident angle is theta 1, and then theta 2 is the refracted angle. So here we go. So now from Snell's law, we can calculate theta 2. So then I have n of class times sine of theta 1 equals n of air times sine of theta 2. So then solving for theta 2, I'm going to get the sine inverse. And this should give me 1.66 times the sine of 25 degrees divided by 1, which then gives us 44.6 degrees for theta 2. Now that I have theta 2, I now use that relationship that we derived. This means now the angle Z is Z 90 degrees minus theta 2, which then gives me 90 minus 4.6, which then gives me 45.4 degrees for the angle C. So now we have all of the angles that we need. So now, look what we said before. When we were looking at this angle, we had a triangle. 90 degrees had to equal y plus z plus beta. So let's go do that. So this is our last angle calculation here. So now we can now solve for beta and 2 beta. And the way we'll do that here is if I just summarize what we have here, note that we have this red triangle. We know that this angle here is beta. We know that this is a right angle, and then we see here that there are 2 angles that we know. We know this angle here is 25 degrees, and we know this green angle Z, this is 45.4 degrees. So now I just got to sum these angles. So now what this tells me here is that 90 degrees has to equal 25, 45.4 plus beta, which then gives us that beta, if I just do this numerically, is then going to give me a value of 19.6 degrees. But we are not interested in beta, we're interested in 2 beta. And 2 beta is then 39.2 degrees. And this is the angular spread.